Today we are going to study about the derivatives of trigonometric functions. Our success criteria is to find the derivatives of trigonometric functions applying the trigonometric rules of differentiation. So here I have written all the formulas. I have collected all the formulas where you can find the derivatives of trigonometric functions. So you can see that the derivative of sine of x is equals to cosine x. We can prove all these formulas with the help of the definition of the limits process. But right now we will apply the direct formulas in order to calculate the derivatives of the trigonometric functions. So the derivative of sine x is cosine x, whereas the derivative of cosine x is negative sine x. Derivative of tangent x is secant square x. Derivative of cosecant x is negative cosec x cot x. Derivative of secant x is secant x tan x, and derivative of cot x is negative cosecant square x. Now, while you will memorize all these formulas, I will just let your attention towards an important information which will help you to memorize all these formulas. It is that whatever the function is starting with the c, its derivative is with negative sign. Its derivative is starting with the negative sign. So this is one hint. You can easily memorize the formulas. Anyway, let's see how to take the derivatives if it is given in the form of a function y equals to, let's suppose, sine of x minus cosine of x, for example. Okay, so how to take the derivative? So you know that this is the sum or difference rule. It means take the derivative of sine x separately and cosine x separately. So derivative of sine x, you can see from the formula, it is equals to cosine x. Then put this negative as it is. Then the derivative of cosine x is negative sine x. So I am writing here to show you negative sine x, but negative and negative gives you positive, so you can even write it directly positive sine x and just copy down cosine x. So this is how we finalize our derivatives. Now let's suppose the question is y equals to 8 sine x minus 4 cosine x plus x square. Let's see this question. Now here we are going to apply the constant multiple rule. Why? Because 8 is multiplying with a function. So what we do when some constant is multiplied with the function, we write the function, the constant as it is, and take the derivative of the function. That means that sine x changes into cosine x. Then again here negative sign, so just write it down because there is no product rule. Now 4 cosine x, so you will write the 4 as it is, the constant, and the derivative of cosine x is negative sine x. So I can write it here directly, negative, negative, positive, and write here sine x. Plus here you can see that the power rule and the basic rule, so just take the derivative, that is equals to 2x. So I hope that you are understanding that how can we take the derivatives. Let's suppose here we have y equals to tangent x plus secant x. Now see how can we take the derivative of such functions. Now derivative of tangent x, you can look at here the formula of tangent x derivative is secant square x, and the derivative of secant x is secant x cot x, the tangent x sec x tan x. That's it. So here you are done with the derivatives, but try to simplify it by taking the commons. So you can see that there is one secant x here and one secant x in the second term. So you will take the common secant x. Now how many secant x left from the first term? Of course there is one secant x. So when you multiply them secant x times secant x, you will go back to the upper position, that is secant square x. Plus now here secant x you already have taken outside, so only 10x is left. So write it down and that would be your final answer. Now what if they ask you to take the derivative of, for example, 8 cosecant x plus 6 cot x. Now you can see that sum and difference, according to sum and difference rule of derivatives, you have to take the derivatives separately. So the derivative of 8 cosecant x. So here you will apply the constant multiple rule. So write the 8 as it is. The derivative of cosec x is negative cosec x cot x. So rather than writing after negative, I will just do it in one step. So put the negative here and write out cosec x cot x. Then plus 6. Now derivative of cot x is negative cosec square x. So again the positive negative gives me negative and I will write here cosec square x. Now take the common. So you can see here in the first term there is 1 cosec x, whereas in the second term there are cosec square x. It means 2 cosec x. So you will write the cosec x as constant. What is left now? Negative 8 and also cot x, because this cosec x is already written outside the bracket. Then this minus sign you will write here. And now what is left from here? Here you can easily see that there are 2 cosec x, right? Cosec x and cosec x. So 1 cosec x is common, so left is negative cosec x. That's it. So this is your final answer. Try to solve one more question. Let's suppose it is y. Let's make more complicated. 8 sine x plus 6 cos x minus 7 tangent x plus 4 cot x. Okay, so take the derivative. So you know everywhere you will use the constant multiple rule and write the constant as it is. Take the derivative of sine x, which is cosine x. Then write plus 6, derivative of cos x is negative sine x. So write here negative and here sine x. Then negative sine, derivative of tangent x. You can see secant is square x. Then plus 4, derivative of cot x is negative cosec square x. That's all. Now it's your turn. Pause the video and just see that how can you take the derivative of these functions. After pausing, come back after 1 minute or 2 minutes, how much time you require to finish all those questions, and then after that check your understanding from the from here. Okay, so the derivative of 4 sine x will be 4 cosine x and negative cos x is positive 7 sine x. Derivative of 8 tangent x will be 8 sec square x plus 9. Derivative of sec x is sec x tangent x. Then the derivative of cosec x will be 6 and cosec x will be negative cosec x cot x. Then plus 0.2, but the derivative of cot x is negative cosec square x. But from here you can take the common. So you can take cosec x common, then left negative 6 cot x, negative 0.2 cosec x. So that would be your final answer. Now from the green one, the derivative of 0.5 cos x will be negative 0.5 sine x. Then negative 6, derivative of sine x is cosine x and derivative of 5 is 0. Y equals to, next question, 8 y prime equals to 8 cot x. It will gives you negative 8 cosec square x. Negative, negative, positive, and cos x, because cos x is negative sine x, so it will gives you positive sine x. No common, that's it. The last one, y equals to 2 by 3, sec x changes into sec x 10x minus 0.1 and 10x changes into secant square x. Again, you can take the sec x common. So finally, you can write here sec x. What is left inside the bracket? That is 2 by 3 10x minus 0.1 sec x. So I hope that all these questions um, very clear and you can understand all the concept and how to apply the sum and difference rules of derivatives, including the trigonometric rules of differentiation. See you in the next part.